Okay. Sorry, I clicked something there. So yeah, when the bases are the same, if you're multiplying, you add the exponents. It's fine to write an example there. So like on this one, x to the fifth divided by x third is x squared. So when you're subtracting, when you're dividing, you subtract the exponents. Okay, when you're dividing, you subtract the exponents. So you really don't need the problem to answer that one. But that is what I'm looking for there. Do you need a paper? Eric, if you want to come grab this paper. All right, Z23X66.
They confused me when they were both negative numbers and we were supposed to flip it, that.
Okay, well, maybe we'll see that one, go over it. If not, we'll pull one up and go over it. Okay, on this one, so this is a division problem. You can, I would look at the z's and then look at the x's. So for my z's, I have 2 on top and 3 on the bottom. If you need to write that out, do it, okay? If you need to write that out, that's not bad. And these cross out, so I have 1 extra on the bottom. I just kind of go through it in my head. I have 2 on top, 3 on the bottom, so that's 1 extra on the bottom. If you subtract, that's fine. The way you subtract is you would say 2 minus 3 is -1. Since that's negative, it goes on the bottom. That's kind of the way to subtract it. But I don't really even do the subtraction. I just kind of look. I have 2 on top and 3 on the bottom, so I got 1 extra on the bottom. My x's, I got 6 on top and 6 on the bottom. So 6 minus 6 is 0, so they kind of go away. If you want to write them out, you can do that. Whatever helps you do these is fine. Okay, 1, 2, 3, 4, 5, 6. I just have 6 on top and 6 on the bottom, so they go away. So my answer is just 1 over z. You would put a 1 on top because the z's on the bottom. So it's 1 over z. -4a4. Is that what it was? -4a4b cubed. Okay. So on this one, you have to take that 3 times everything inside there. So you would want to, I'll go back and fix those questions later. You would want to figure that how many exponents are inside here. You are going to take everything to the third power, okay? So this is -4 to the third power. A to the fourth to the third power. That'd be 4 times 3, that'd be 12. And over here, the b to the first, that would be b cubed, okay? So you want to make sure you do the -4, the a, and the b, everything inside of there. -4 times -4 times -4 would be -64. So -64, a to the 12th, and b cubed. So you always simplify the number if you can. Make sure you take everything inside there to the third power. X -4, x -6. Here's the problem you were just talking about. Okay, so if you have negatives right here, to get rid of a negative, you can do this a couple different ways, but I'd always get rid of the negatives first. To get rid of this negative, I bring it down here. Okay, to get rid of this negative, I bring it up here. So I drop this one down, and this one goes up, and that makes it positive. Now I have 6 x's on the top and 4 on the bottom, so I got 2 extra on top. If you need to write it like this, just to make sure, that's fine. Like you got 2 extra x's on top. The alternate way of doing this is to do the subtraction, which is hard with the minus and negative, but -4 minus a -6. -4 minus a negative, that becomes plus. So this is +2. When it's positive, I put it on top. When it's negative, I put it on the bottom. I just don't do the subtraction very often because I mean, it does work all the time, but it does get a little confusing with the minus and negatives. So as soon as I see a negative, I drop it down. As soon as I see a negative on the bottom, I move it up. And then I do, okay, I got 6 x's on top, 4 on the bottom, so I got 2 extra x's on top. The Wi-Fi has been kind of silly today, so... Oh, man. This one looks like scientific notation, doesn't it? How did it go away?
Yeah.
Okay, so scientific notation, they may talk about left and right, but I don't really like talking about left and right because it's opposite when you switch what you're doing. So for A right here, 1.21 times 10 to the fourth, and I want to write this in standard notation. So the way I think about it is this is a positive number, so I want it to be bigger. I want it to make it bigger. So how do I make 1.21 bigger? I'm going to move it to the right. So I do 1, 2, 3, 4. So that would be, what, 12,100? And then for B, we're going the other way. What is there, 4 zeros there? Write it in scientific notation. So I'm going 1, 2, 3, 4. 5 would make it 2.68. Remember, you're always a number between 1 and 10 times 10 to something, right? So it's always a number between 1 and 10. So I do not want to stop here because that would be 0.2. Well, what happened? But if I stop right here, that'd be 2.68. So I moved it 1, 2, 3, 4, 5 times. On this one, it is going to be negative because it's a decimal type number, okay? I don't remember left and right. I just know that if it's negative 10 to the negative exponent, it's like a decimal. It's a super small number. If it's a positive exponent, it's going to be a bigger number, like 1,000 or 100 or million or 10 million or whatever. That's the easiest way because the problem with left and right is if I'm going from scientific to standard, the left and right switch when I go from standard to scientific. So it's kind of confusing. So just remember, if it is a super small decimal type number, it is going to have a negative exponent. All right, number 5 is on our show or work page. 4y plus 1, 7y plus 2. Oh, whoops. I don't want that button. Okay, so most of you probably know what to do on here. You are going to FOIL, right? First, 4y times 7y would be 28y squared. 4y times 2 would be 8y. 1 times 7y would be 7y. And then 1 times 2 would be 2. And then you can just add up the like terms. So 28y squared plus 15y plus 2. So all first, outside, inside, last. And remember, all FOIL is an acronym to make sure that we are multiplying everything in the left one times everything in the right one. So I take this 4y times both of these, and then I take this 1 times both of these. $18, 14, 12, 2. That was pretty close. Oh, it's 654. It doesn't matter. It'll be the same thing, but we can do it. All right, when you do this one, what you are actually doing is dividing all of them by 2u squared. So if you need to write them out like individual ones, you are welcome to do that, if that helps you. Or you can just go through the process of saying, okay, I'm taking a 18, I can do 18 divided by 2, okay? So on this one, 18 divided by 2 is 9. Why did I write a 6 there? That's a 2. I got 6 u's on top and 2 u's on the bottom. So that would be 4 u's on top. On this one, 14 divided by 2 is 7. I got 5 u's on top, 2 on the bottom. So I got 3 u's left over on top. On this one, 12 divided by 2 is 6. 5 u's on top, 2 on the bottom. I got 3 u's on top.
This should be a 4 right there for the 12.
My goodness. Should be a 4, shouldn't it? It's kind of been one of those mornings for me, so y'all need to double check me. Can't write stuff down. Yeah, I just wrote it down wrong. It's 4 u's and 2 u's, so you get 2 u's left over. Six UV5, 6 UV5Y4. U8V9. Okay, so it says to factor. What you're doing here is pulling out the greatest common factor. So the greatest common factor of my numbers, 6 and 21, would be 3, right? With the exponents, you take, for the greatest common factor, it's always the opposite for the exponents. You take the smallest exponent. And the reason being is because I cannot pull, like on my V's right here. I have, well, that's the U. If I have 5 V's on the left and 9 V's on the right, I can't take 9 V's out of here. So I can only take 5 total. So my U's, I have 1 U on the left and 8 U's on the right. So I can only take 1 U out. My V's, 5 on the left, 9 on the right. So I can only take 5 V's out. And this one doesn't have any Y's in it at all, so I can't do anything with that. So I do 6 divided by 3 is 2. I take away one of these U's. There's only one there, so it goes away. I take away 5 of V's, so they go away. And then 21 divided by 3 is 7. My goodness, see, I just wrote 5 there. 21 divided by 3 is 7. I take away one of these 8 U's. So I have 7 U's left. Take away 5 of these V's, so I have 4 V's left. And remember to check your answer. You can always distribute it back through. Six U2 minus 78U plus 72. All right, so this is another factoring problem. I'm sure the next few are factoring, but the first thing you always want to check for is your GCF. That makes you have smaller numbers. So all of these I can divide by 6. Okay. So if I divide them by 6, U squared minus 13U plus 12. Now go through my factoring steps and say, okay, what multiplies to be 12 and adds up to be negative 13? This would be negative 12 and negative 1, right? So I put my two binomials. U times u is u squared. Negative 12 times negative 1 is positive 12. And negative 12 minus 1 would be negative 13. And that would be my answer. You do have to put the 6 on there, but remember, it's computer math. I know it's not perfect. You can always check your answers afterward, and if that doesn't work, I'm sorry, if you like just forget to put the 6, but you put it on your paper or something like that, I can give you partial credit on this stuff. $25u plus 25, 40, 16. On this one, these are big numbers, right? But hopefully you recognize, don't I know the square root of 25 is 5? And the square root of 16 is 4? So when there are perfect squares, it's usually a shortcut one. So the way you can do this, 5u times 5u is 25u squared. 4 times 4 is 16. And since this sign is in the middle, you write plus. You can also write your answer like this, because it will always end up being the same thing. So 5u times 5u is 25u squared. 4 times 4 is 16. Sign in the middle is plus, so it's a plus. When you see perfect squares on the beginning, on the end, it's usually one of those shortcut ones like that. Number 10 is a show your work one on the page. Negative 30, negative 25 equal 9. Which one had my u? Negative 30u, okay. Let's go double check this one more time. Negative 30u minus 25 equal 9u squared. Okay. All right. When you see a u and a u squared, your mind goes to factoring, and the first thing you want to do is set it equal to 0. Okay, so I need to get everything on one side. I never want to make this negative. So what I want to do actually is I'm going to add 30u and add 25 to both sides. So I have 0 equals 9u squared plus 30u plus 25. Do y'all notice anything about this one from our last problem?
Perfect square.
They are perfect squares. So maybe I can just 3u times 3u is 9u squared. 5 times 5 is 25. And then since this is a plus in the middle, I write plus on both sides. Since this is equal to 0, I am going to set both of these equal to 0. We hadn't had an equation yet. This one actually has an equal sign in it. So I subtract 5 from both sides and divide by 3. Now, these are the same exact thing, so I don't really have to do both of them, because I know I'm going to get the same answer. It's okay to just get one answer. It means you can have up to 2 answers. I need to see if that one always works like that. I'm gonna work that one on here. All right, getting into some rational. These are like 4 different problems of factoring, but as soon as I see divide, I am thinking keep, switch, flip. I'm going to flip the second one, okay? You do not forget to do that. So now I go through each one. In the upper left, I'm looking at what multiplies to be -2 and adds up to be 1. So that would be +2 and -1. So x times x is x squared plus 2 minus 1. 2 minus 1 is +1, and 2 times -1 would be -2. Okay. Bottom left. No, I need to come up with some new colors here. Bottom left. They both have a 3 in it, so I can factor out a 3. Now, here's where you got to be careful. X plus 1, I'm going to write up here because I flipped that second one, right? And then bottom right, I'm doing what multiplies to be 6 and adds up to be 5. That'd be 3 and 2. 3 times 2 is 6. 3 plus 2 is 5. If you do it all right, there should be some stuff that cancels out. At least one thing cancels out. So I have an x plus 1 and an x plus 1, x plus 2 and x plus 2. So on the top, I have x minus 1. On the bottom, I have 3 and x plus 3. What's the next one? 13 and 14 we should work on. One 3b plus 5. Okay, don't miss the easy ones here. I know this one looks hard, but don't miss the easy ones. When you are adding or subtracting, the denominator stays the same. Then all I do is take the numerators and do what they do. 1 plus b is just 1 plus b, and that's it. Eight, 7, 5, 4. Okay, so now we did one with the same denominators. These have different denominators, so I need to figure out my LCD. The LCD, it's the biggest exponent. I don't think you're going to have to deal with that too much. But of 7 and 4 would be what, 28? So 28a. So now I need to change this denominator to 28a, and I need to change this denominator to 28a. So how do I go from 7a to 28a? I would have to multiply by 4, right? But if I multiply the bottom by 4, I need to multiply the top by 4. Now do the same thing with the fraction on the right. How do I go from 4a to 28a? I'm going to multiply by 7. But if I multiply the top bottom by 7, I need to multiply the top by 7. And then we do like we just did before. The denominator stays the same. 32 minus 35 would be -3. $14 is on our show or work page. 448.27. Or this is 13, isn't it?
No, just the 13.
The last one was 13.
The last one was 13?
Yeah.
Yeah.
Man, okay, I'll copy that over. So yeah, you are supposed to show your work on that one. What was this one? 448.27? Okay, so yeah, you do need to show your work on that one. 448.27. All right, now on to radicals. So first, you cannot add these. They have to be the same to be able to add them, so you want to reduce them down. So if I divide this by, just divide it by 2 if you can't think of anything. Most of y'all are probably going to think 6 and 8, though. So 2 and 3, 2 and 4, 2 and 2. So I have a pair of 2s. Actually, I got 2 pairs of 2s, don't I? How can I draw this? Woo. There's a pair of 2s and there's a pair of 2s. Right? So these come out and these come out. So if I already have 4 out there, and then another 2 comes out there, and another 2 comes out there, and then this 3 right here doesn't have any friends, right? It stays in. So 4 times 2 times 2 would be 16.
Is this for recording?
Yes.
See, the other one didn't have the voice recorded.
Seriously?
Yes. As I went to, like...
The one that I talked for like an hour?
It wasn't showing the audio.
Oh, I probably forgot. That day with the classroom. Oh, my goodness. Okay. So 27 would be 3 and 9 and 3 and 3. So the 3 comes out. I guess I can write that here. And this 3 doesn't have any friends, so it stays in. So when I go to add these, now they are the same. I have 16 of them plus 3 of them, so I have 19 of them. I can't believe that. I've talked for like an hour and I didn't have the audio on the last one.
The microphone's not a thing.
Huh. $3 and 27. When you multiply these, you can kind of go about this 2 different ways. You can go ahead and simplify first. That would make smaller numbers to work with. That's probably easier. We kind of just did 27. So this is actually 3 comes out, and then that one doesn't have any friends, so it stays in. So you write the pairs on the outside. And then when you do this, it's inside times the inside and outside times the outside. You do not mix them. So the 3 is on the outside. 3 times 3 is on the inside. Well, that's just 3, right? 3 times 3, my answer here becomes 9. The other way is to go ahead and multiply them first. On this one, it actually ends up being easier. 3 times 27 is 81, and the square root of 81 is 9. That doesn't always end up easier, but you always get a bigger number to work with. But you can do that either way. Three U2Y4 6UY4. All right, on this one, you do want to go ahead and just multiply these first. These aren't big numbers to work with. Thank you. So 3 times 6 is 18. You got 2 U's over there, 3 over here. Or 2 on the left, 1 on the right ends up being 3. 4 Y's on the left, 4 Y's on the right. That ends up being 8. So now you can go through the simplifying steps. 18 would be 9 and 2, 3 and 3. So here a 3 comes out and a 2 stays in. For the U's and the Y's, you can write them out and do the same thing. Okay, one pair comes out. That one doesn't have any friends, so it stays in. My Y's, 5, 6, 7, 8. 1, 2, 3, 4 pairs, so they come out. Okay, you can write them out. The other way to do it is divide it by 2. 3 divided by 2 is 1 with a remainder of 1. So 1 comes out, 1 stays in. My Y's, 8 divided by 2 is 4. So that means 4 comes out. And if you want to write a remainder of 0, 4 comes out and 0 stays in. And then my last problem, this one is on the show your work page, 2y. And I will make sure to copy that other one over here. All right, so on this one, you can rewrite this as the square root of 2 and the square root of y. But you cannot have a radical in the denominator. To get rid of the radical in the denominator, you multiply by itself. On the top, inside times the inside. On the bottom, square root of y times the square root of y would be the square root of y squared, right? But that's 2y, so that's a pair. They end up canceling out. So my answer, that's why we multiply by itself, because it will always cancel out. So what happens is you multiply a radical by itself, you end up with what's just underneath. Do not cancel these out, because this is under the square root and this is outside the square root. So you cannot cancel those out. Now, before I stop real quick, I want to go back to number 10 because I feel like we got an easy one there. Yes, we did. 4v2, 5v6. Plus 5e equals 6. Okay, I feel like we got an easy one the first time because it was a square root one again, or perfect squares. So on this one, again, you set it equal to 0, so I'm going to subtract 6 from both sides. So I have 4v squared plus 5v minus 6 equals 0. So now I go through my factoring steps. There's no GCF. There's nothing that 4, 5, and 6 all divide into. So I do 4 times negative 6. You're most likely going to get a problem like this. You're not going to get lucky and get one easy like I had last time. So what multiplies to be negative 24 and adds up to be 5? This is going to be positive 8 and negative 3. So I write 4v at the beginning of both of these because I multiplied by 4 at the beginning of both of them, at the beginning of the problem. And then I'm going to write plus 8 and minus 3. That's not correct, though, because I can divide both of these by 4, and I get v plus 2 and 4v minus 3. What happens on this problem is we multiply by 4 at the beginning, so we write 4 at both of these, and we divide by 4 at the end. Multiply by 4 at the beginning, so we divide by 4 at the end. Now, to finish this problem, I do need to set both of these equal to 0. So here I subtract 2 from both sides. And on this one, I add 3 to both sides and divide by 4. So I do get 2 answers on this one. Okay. Most likely, that problem is going to look like that. If you have trouble putting the show your work on that one, honestly, the part that I want to see is the factoring. So once you get to like this line right here, that's all I really want to see. I mean, most of y'all can handle putting your work in there, but I just want to make sure I did that one because I feel like I got an easy one the first time. This is probably going to be what your problem looks like, is one of these though. Okay.